Hello, this is Mr. Huber. In this lesson, we're going to learn about how to solve quadratic equations by completing the square. Completing the square refers to completing a perfect square trinomial. So let's recall, when we multiply x plus 9 squared, like we'd see here, right, we are going to get x squared and then plus 81 on the end, and our middle term is going to be these two multiplied together and then doubled, because we'd have a 9x and a 9x in the middle that would add together and give us plus 18x. We want to know that special pattern for squaring a binomial. All right, we can reverse that process, right? We could factor that. If we see a perfect square trinomial, this is a perfect square trinomial right here. If we see that, we want to recognize that this is 9 plus 9, and this is 9 times 9, right? And that would give us the x plus 9 squared. So examples of that we see below here, right? If we have x squared plus 6x plus 9, this is 3 times 3, 3 plus 3, so we get x plus 3 squared. 25 is 5 times 5, and then here we want to recognize it's negative 5 times negative 5, because negative 5 plus negative 5 gives us the negative 10, so we'd have x minus 5 squared, right? So recognize the pattern here. If we take this b value and divide it by 2 and then square it, because this is something added to itself, so that would be cutting it in half and then squaring it, cutting it in half and squaring it. So the c value will always be b over 2, the b over 2 value squared. The c value to complete the square will always be take the b value, divide it by 2, and then square it. So let's see what that looks like in some problems where we're going to be asked to complete the square. So we want to find the value of c that completes this square. Looking at number 1 here, to find the c value, we're going to take the b value, negative 12, and divide by 2, and then square it. So negative 12 over 2 is negative 6 squared, would be c is equal to 36. As a binomial squared, we'd have m minus 6 squared. So pay attention to the sign here, minus 6, because we have a minus in our middle term. This c value is always going to be positive, because whether you square a positive or a negative, we multiply by itself, you'll get a positive. Right? In number 2, so we're going to take the b value, divide it by 2, and square it. So we're going to have 5 over 2 squared. And we could write this as a decimal or a fraction. I'm just going to keep it as a fraction. So c would be 25 over 4. If you did have it as a fraction, that's fine. Then you'd have 6.25, because you have 2.5 squared, which is 6.25. And then our binomial would be x plus 5 over 2 squared, or you could write x plus 2.5 squared. Either of those would be fine, whether you want the fraction or the decimal. So to find that c value, to complete a perfect square, take the b value, divide it by 2, and square it. Completing the square can be used to solve quadratic equations, because we want to get that binomial squared on one side, and then we'll be able to square root it. So we're going to see what that looks like. In order to do it, we got to make sure that we get the ax squared and bx on one side of the equation and some other value on the other side, so we can complete the square. We're going to fill in what that c value is. All right, so in this example here, right, we want to look at this like we're trying to add in what's the c value, plus c, right? What is that c value? So in order to do that, we're going to take the b value and divide it by 2 and square it. So we're going to have y squared minus 16y, and then 16 divided by 2 is 8 squared is 64, equals negative 15 plus 64. If we add 64 on one side of an equation, we have to add the same thing on the other side. So when we complete the square, we need to make sure that whatever value we're adding to complete the square, we do the same thing on the other side of the equation. And now that left side we can write as a binomial square. This is y minus 8 squared equals negative 15 plus 64 is 49. And now if we look at this left side of the equation, we can square root this. We've solved equations by square rooting before, so now we can use that method to square root both sides. And we're going to get y minus 8 equals plus or minus 7. Don't forget the plus or minus. So we're going to have y minus 8 equals 7, and y minus 8 equals negative 7, right? Plus or minus. And then when we add 8 to both sides, we're going to get y equals 15 and y equals 1. So y equals 15 and y equals 1 would be my solutions. You could check those, plug them back into the original equation, take these and plug them back in up here in the original equation, make sure it makes the equation true. So complete the square and make sure then that you add that c value onto both sides of the equation. Right? In number 4, the first thing we actually need to do is subtract 2. We want to get the m squared and 8m by themselves on one side of the equation. So when I do that, I'm going to get m squared plus 8m equals negative 7. So now I need to complete the square. So in order to complete the square, I'm going to have m squared plus 8m plus, take 8, divide it by 2 is 4, square that is 16, equals negative 7 plus 16. And I can write this then as a binomial being squared, m plus 4 squared equals 9. Now I can square root both sides. All right, I'm going to get m plus 4 equals 3, m plus 4 equals negative 3, right? Plus or minus the square root of 9. And now I can subtract 4 on both sides, m equals negative 1, subtract 4 on both sides, m equals negative 7. So negative 1 and negative 7 would be my two solutions to that equation. So again, going back, find the c value that will complete the square. Make sure you have the variable squared and the variable to the first power on one side. So the ax squared and bx on one side. Okay, that's why we had to subtract 2 over here. So we get ax squared plus bx and then some value on the other side. Then find the c value that completes the square. So you can write it as a square of a binomial. Now when you have, in this situation, here and here, you can square root both sides to cancel out the squared and have your equation to solve. Make sure you include the plus or minus on the other side of the square rooting. All right. Before we solve some more by completing the square, a little tentacle trivia. The plural form of octopus, a lot of people want to say octopi because maybe it sounds fun or better, but it's not. Octopi is not the preferred plural. This octopus comes from Latin and actually Greek. The Latin form would make you think octopi would work, but it's actually Greek roots, and so octopodes would actually be the technically most correct plural from the Greek roots, but English version of it, octopuses. So octopuses is actually the most preferred plural form of octopus. All right, now that we've gotten that out of the way, let's solve some more equations by completing the square. So in this next example, we want to get the ax squared plus bx on one side of the equation. And before we do that, or after, it doesn't matter which you do first, you can divide everything here by 2. I'm actually going to do that first, but if you add 8 to both sides and then divide by 2, that's fine. I'm going to divide everything by 2, okay? And so when I do that now, I'm going to have x squared plus 10x minus 4 equals 0. Right? 0 divided by 2 is still 0. All right, and then I can get that as x squared plus 10x equals 4. Right? And I left a little blank here because that can be a nice way to write this out because I know I'm going to have to fill in a number there to complete the square. So I'm going to take 10 divided by 2 is 5, squared is plus 25. And then I can do the same thing on both sides, add 25 to both sides. All right, now I can write that as a square of a binomial, x plus 5 squared equals 29. All right, so now when I do this, I'm not going to get an exact value for the square root of 29. So that's fine. I can have decimal values. So when I do this, I'm going to have x plus 5 equals plus or minus the square root of 29. So I have x plus 5 equals the square root of 29, and I have x plus 5 equals negative square root of 29. And I have to put that in my calculator. So I'm going to subtract 5 from both sides. So when I do that, on the left side, when I subtract 5, right, I'm going to have x, and we'll round it off. We're going to go a couple decimal places. So I'm going to have the square root of 29, and then I'm going to need to subtract 5 from it. So you're going to need your calculator to find the square root of 29. When you do that, it should come out to about 5.385 in a repeating decimal, and I subtract 5, and you're going to get about 0.39 rounded. So 385, so we'll round that 8 up to a 9. And now we're going to take negative square root of 29, and we're going to subtract 5 from that. And when we do, we're going to get x is about negative 10.39. All right, so there's our values for x. You can use a calculator, plug those square roots in. Even if it's an exact one, square root of 64, which comes out to exactly 8, maybe you don't know how to do the square root without a calculator, that's fine. Use the calculator, get that root. Don't forget the plus or minus, whether it's an exact whole number or whether it's a decimal. All right, now we're going to go to number 6. In this case, again, I could divide everything by 3. I can divide everything by 3 to simplify. I'm going to get x squared plus 27 equals 8x. And now I needed to subtract 8x on both sides and subtract 27 because I need to get the ax squared plus bx on just one side. give myself a little more room over here. So when I do this, I'm going to get x squared minus 8x equals negative 27. Okay? And I could take this now and complete the square. So I'm going to find the c value. Right? What's the c value here? We're going to take negative 8 divided by 2 is negative 4, squared is 16. So I'll have x squared minus 8x plus 16 equals negative 27 plus 16. Okay? This comes out to x minus 4 squared equals negative 11. And when I go to square root both sides, I'm going to have an issue. Right? When I try to square root a negative, right, that's going to be an issue. There's no solution. Okay, no solution. I can't get a square root of negative 11. So no solution on that one. So look for that when you're square rooting, or you still can't square root negatives, whether you're doing it some other method or completing the square. All right, let's look at number 7. So number 7, again, we want to look for it. There's a common factor I can divide all these by, so I'm going to divide everything by 2. I'm going to get n squared plus 6n plus 7 equals 0. And then I need to subtract the 7 on both sides. I'm going to have n squared plus 6n equals negative 7. And now I can complete the square. So I'm going to do plus 9. 6 divided by 2 squared plus 9. All right, so then I'm going to have n plus 3 squared equals 2. That was a 9 there. And now when I square root both sides of this, right, so I'm going to square root both sides. I'm going to have n plus 3 equals the square root of 2. And n plus 3 equals negative square root of 2. Don't forget plus or minus. The square root of 2 is going to be some decimal that we can get an answer for here when I subtract 3 on both sides. So I'm going to have the square root of 2 minus 3. So the square root of 2 and then minus 3. Square root of 2 is about 1.41, and then minus 3, we're going to get n is about negative 1.59. And then I'm going to have negative square root of 2, and I'm going to subtract 3, and I'm going to get n is about negative 4.41. Okay, so make sure that you're checking that you know how to enter these types of things in your calculator. You should be doing these as well on your own. So if you're not using the calculator properly, we can get those things figured out so you can use that tool to your advantage properly. All right, so find common factors if you can to simplify the equation. You want to get the ax squared plus bx plus c, ideally having a 1 in front of that x squared, that a value being a 1. Now we can complete the square. All right, we complete the square by taking the b value, dividing by 2, and squaring it. Make sure you do that on both sides. When you get to here, again, we have your binomial squared square root to cancel out the squaring, and make sure you have your plus or minus on the other side of the equation. All right, so we've got another one here. We can solve this by finding the c value. So we're going to have x squared plus 10x plus 25 equals negative 8 plus 25. And now I'm going to write that as x plus 5 squared equals 17. When I square root both sides, I'm going to have x plus 5 equals the square root of 17. X plus 5 equals negative square root of 17. So that I can subtract 5 from both sides. Right? Subtract 5. So I'm going to get x, and I'll get my two values for x by doing the square root of 17 and subtracting 5. And that gives me negative 0.88. And then my other value is going to be negative square root of 17 and subtracting 5. That's going to give me negative 9.12. 9.12. All right. So there's my two values for x for that. And I can plug those back in. If you plug in the rounded decimals up here, it's not going to give you exactly the solution because you're using a rounded decimal. If you kept it exact, using exact information from your calculator, that'd work a little better. But if you plug in these rounded decimals, it's going to come out close to equal on both sides, but not exact. So just be aware of that when you're checking those rounded answers. All right, so completing the square, you take the b value, divide by 2, and square it. That gives you the c for the perfect square trinomial. You can write that as a square of a binomial. And then using that to solve, we can square root both sides. And don't forget that plus or minus when you're square rooting just any number on the other side of the equation.